What's up, everybody? This is Gradius, and this is the video for graphing quadratics in standard form. So what we're going to be doing is we're going to be graphing quadratics that look like this form right here. This is considered standard form. I did not mean to cross that out. This is standard form right here. So instead of being in vertex form, which is what we've done previously, vertex form is when we have it looks like HK form, x minus h squared plus k. So this is vertex form. Now we're going to graph quadratic functions that look like this. Okay. So first thing you need to know is we need to know which value is our a, which value is the b, and which value is the c. It's very important to know that information because we need that in order to graph these because we are going to use a formula that involves a, b, and c. Also, what we have to know is we have to understand what the axis of symmetry is. So the axis of symmetry is the line that passes through the vertex and divides the parabola in half. So this vertical line right here is going through my vertex, and it is dividing this parabola in half. So they're symmetrical on both sides, where if I folded this side of the parabola over this way, they should be right on top of each other because they are symmetrical. Okay? And that axis of symmetry is just, it's almost like an imaginary line. I mean, it's real, it's there, but we never actually draw it. Okay? But it goes through the x-coordinate of our vertex. Okay, so it always goes through the vertex, and especially through the x-coordinate of the vertex. All right, now let's look at all the steps of what we need to do in order to graph a quadratic equation in standard form. So here is a quadratic function in standard form. I have 3x squared minus 6x plus 2. So again, I rewrote what each piece means. So here would be my a, this would be my b, and this would be my c. It's important to know a is always attached to the x squared, the b is always a coefficient that's attached to my x, and the c is always your constant. Now, first thing we do when we graph these equations, we determine if they open up or down. So is my a positive or negative? So this is still going to determine which way the parabola is going, okay? So because 3 is positive, it is going to be going up. Okay, so it will be a u that's facing up. Now what we do is we want to find the axis of symmetry. This formula right here is the formula we use in order to find the axis of symmetry. Okay, and that's going to give us the x-coordinate of our vertex. So we use negative b over 2a. Okay, and then so we have to know this formula in order to find our vertex, because this is going to give us the x-coordinate of our vertex, and then once we find the x-coordinate of our vertex, we plug that in to figure out what the y-coordinate of our vertex, and that'll give us our vertex, and that's step 3. And then we can plot 2 points by plugging them in on either side of our vertex. Okay, so let's look at this. So again, I have the same exact function, 3x squared minus 6x plus 2. So I have negative, make sure I get it right, yeah, negative b over 2a. Okay, so now what I need to do is I need to find my vertex. So negative b, so that's negative, and whatever b is negative 6. Okay, so that's going to be negative. It's going to give me a double negative there. All over 2 times a. 2 times 3. My double negative makes it positive. So I have 6. I want to simplify this. Over 2 times 3 is 6, which is just 1. So for my vertex, I know the x-coordinate is 1. What I just found is I just found the axis of symmetry. So technically the axis of symmetry is right here at x equals 1. So that means the left side of this line is symmetrical to the right side of this line of my parabola. Okay, so here's my axis of symmetry. Now what I need to figure out is, because I know my vertex is somewhere along this axis of symmetry, I've got to plug in 1 into my function to figure out what the y-coordinate is, to figure out where this graph starts. So I have 3 times 1 squared minus 6 times 1 plus 2. So I'm just plugging it in to figure out, plugging in the x value of my vertex to figure out what the y is. 1 squared is just 1 times 3, so this simplifies to just 3 minus 6 plus 2. Okay, and that's going to give me, let's see, negative 3 plus 2, this is going to give me negative 1. So my vertex is at 1, negative 1. I'll plot that in blue here, which is going to be here. So there's my vertex. Now what I can do is I just want to get 2 points on both sides of my axis of symmetry, so 2 points on each side for my parabola. And remember, all you really need to do is actually plot the 2 points to the right, and that's just going to give you, because the left side's symmetrical, it'll give you the values to the left as well. So the way I know what points I want to plug in and look for is because my x is 1 here, I need to know what values what my y is for x is 2, because that's my next point over. So I can plug into my function and graph from there. Okay, 2 squared is 4 times 3 is 12. Minus 12 plus 2. And you'll notice 12s cancel out, so I just get y as 2. So 1, 2. And it's going to be symmetrical on the other side. And then finally, I would plug in x equals 3. So it'd be 3 times 3 squared minus 6 times 3. And then there's supposed to be a plus 2. I'm just going to squeeze it in here because I'm running out of room. 3 times 3 squared is 9 times 3 is 27 minus 18 plus 2. I'm left with 11. Okay, so then for here, I'll go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And it's symmetrical on the other side here at negative 1. There's my parabola. Not the best looking parabola, but it works. Okay, so let's do just one more example because they're pretty much all the same. Let's look at this one. Okay, because this previous problem, you guys, if you want to try it, go ahead. But this one's the same exact process as this one. The only difference with this one is because my A is negative, my graph should be opening down. Okay, so this one would be opening down. So it would be a parabola that is going this way, but we still would find our vertex by using our formula. But let's take a look at this one because this one's a little bit different. So now I don't have a middle value here. I don't have a b. Okay, so I know my vertex formula is negative b over 2a. But I don't have a b. Okay, so if I don't have a b, if we look at it, it's just going to be 0 over 2 times a, which is 1. But as soon as I have, because b is 0 here, so when I plug that in, that means that my x value for my vertex is 0. Okay, so the y-axis is my axis of symmetry. Okay, because whenever you have 0 in your numerator, the answer is just going to be 0. Okay, so I know for my vertex, my x value is 0. Okay, so that is fine. Okay, and then I can then plug in 0 in for x and figure out what my y value is going to be, and we'll look at it right away. I mean, I can plug it in for you to show you, but it is just going to be negative 6 because 0 squared is just 0. So 0, negative 6 would be the vertex. 1, 2, 3, 4, 5, 6. Okay. Now that I have my vertex, I can then plot the points on the right and the left. But again, if we just plot the points on the right, the left side is symmetrical. So I can plot the points for 1 and 2, and that would also give me the points for negative 1 and negative 2. If I plug in 1 squared minus 6, I will get negative 5 because 1 minus 6 is negative 5. So the left side is symmetrical to the right side. If I plug in 2, I'll get 2 squared minus 6, which is 4 minus 6, which is negative 2. So here we are. The left side is symmetrical, and I'm good to go. Here's my parabola. So that's it, guys. I mean, the biggest thing with this one is to make sure you just get your vertex first with this formula. We have to know this formula to find our vertex. So once you find your vertex, it's no different than what we've been doing in the past. Is then once you find the vertex, you start plugging in values for x to figure out what your values for y are, like an input-output table type thing. Like, okay, so that's it. So make sure we have these steps down right here. Okay, make sure we have this formula down. Make sure we understand where our a value, where our b value, and where our c value are, because we need to know that for the future anyways. And then go ahead and get some practice on this, okay? And then also quick jokes for you guys before you guys leave. What does a little mermaid wear? What does the Little Mermaid wear? An algae bra. Okay, all right. Hope this video helped, guys. Let me know if you have any questions. All right, later.